Chapter number 6. The title is Rotational Mechanics. And here in the diagram, there are so many types of the motions are there. And here, this is a revolution. Like this is a revolution. If anything is moving like this, so the name of the motion is a revolutionary motion. But if something is rotating like this on the axis here, so this is a rotation. This kind of motion is a rotation motion. Here also the pictures are given for the rotational motion, and this is a small definition for the rotational motion. Can be defined as the motion of an object around a circular path. Like this kind of motion is a example of the rotational motion. So here there are so many diagrams are given which is representing the rotational motion, okay, of the objects. Now, so the formula starting from here, there is a term that is the angular displacement, and this is denoted by the theta, del theta or the theta. This is a angular displacement. So like in this diagram, this is showing one rotational motion, and if this is the position, okay, the A is the position of the object, and the object is going to the B, and the object is going to the B, and this is the radius of the circle, and this is the radius of the circle. So the formula for the angular displacement is the theta equal to the s over r. So what is this s here? This s is basically a arc, or the length of the path which is moving from A to B. So this length is a we actually we are saying this is a arc. The exact name is a arc AB. Arc AB means the length of that part, okay, on the circle, and here it is denoted by the s, and the theta is equal to the s over r. So this is actually, here we have the two formulas for the angular displacement, and this is the rule number 1, and this is the rule number 2 for the angular displacement, and this is the formula for the angular displacement. So here the formula is the del theta is equal to the final angular position, the final theta, and the initial angular position. Like this is the theta I, difference between the two. So what is this the theta I and the theta F? Okay, for example, in this diagram, the object started from the position A. So with respect to this line, in terms of the angle, so this position in terms of the angle, here it is denoted by this theta I, and if the object is moving up to, okay, up to the point B, like up to here, then it moved some angle, okay, and the angular position, okay, so the angular position at this point, this is denoted by the theta f. So this is the difference between the final angular position and the initial angular position. So this is the second rule for the angular displacement. Now, so regarding the units of the angular displacement, we have the three units basically, okay, like the three units are there, and we can use all, and we can show the theta, the angular displacement, in terms of the degree, something like this. If I say this is 20 degree, like that. Okay, so the value of the angular displacement is 20 degree. Okay, so this way we can show. And also it can be shown in the unit of the revolution. So what is the meaning of the revolution? Okay, so here this is a small definition for the revolution: a complete round trip of a rotating body. Okay, so the meaning is, for example, if the body starting from here. Okay, okay, for example, if the body is starting from here, so if the body start okay, if the body starting from here. Okay, so if the body is starting from here, and then okay, so for example this is the start point, and then it is making a circle, okay, moving like this, so like from here to here, and then coming like this, so this is a stop, only one circle. Okay, so here this is only one circle. Okay, this is only one circle, and this only one circle, only one time, like only one time, not two times. Okay, so only one circle is known as the one revolution, okay, of the motion. This is one revolution. Okay, so sometimes we are, okay, showing the unit, okay, the unit of the displacement, okay, angular displacement, like how many revolutions are there. And also okay, and also if I move one circle, okay, so if I move one circle, okay, like this, if I move one circle, so in terms of the degree, okay, in terms of the degree, this is the full circle. Okay, and the degree of the full circle, this is 360 degree. In terms of the, this is the symbol of the degree, this is the symbol of the degree, and we are saying degree. Okay, and this is also same if I say how many revolution, so this is one revolution. Okay, so this 360 degree, this is equal to, in the unit of the revolution, this is one revolution. Okay, so if for example if I am moving second time, okay, so how many revolution now, so this is the two revolution. Okay, if I move the two times, so two times means how much this angle, the double of that. Okay, so this will be 720 degree angle, like that. So the one revolution is equal to 360 degree, and this is the third unit, okay, that we can express the angular displacement. Okay, the angular displacement in the unit of the radian. Okay, in the short form we are writing the radian dot, like that. And here the meaning of the radian means, if I, okay, so if I start from here, okay, so if any object is starting from here and then making the one revolution, okay, or one circle. Okay, if it makes start from here and then stopping here, then stop. Okay, then stop. So this is a one circle. Okay, one circle or the one revolution, same meaning. So this, okay, so this one circle, okay, this one circle, or okay, one revolution, this is same like 360 degree in degree. Okay, and also this is same like, this is also the angle, the 2 pi, so the 360 degree, or the 2, see if I write 360, okay, so if I write this number and the unit is here, this is the unit of this number 360 degree. Okay, so here it is degree, like that. And in, but in another unit, the radian, okay, so the 360 degree is equal to the 2 pi. So the 2 pi has like 2 pi radian, so this is, we are calling here, this is radian, here it is radian. So the meaning is, okay, so the meaning is 360 degree, okay, it is degree equal to the 2 pi radian, so they are same, they are same. So this is the relation between the 2 pi, the 2 pi, the 2 pi radian is equal to 360 degree, like that. And if I okay, if I calculate, okay, if I calculate further, okay, to make it a smaller number, okay, so we know the 2 pi is equal to 360 degree, okay. And the 2 pi, okay, the 2 pi radian is equal to 360 degree, okay, like that. So this is the 2 pi radian equal to 360 degree, okay. But I want to know what is the value of the 1 radian, okay. This is 2 pi radian. So if I, okay, so if I say what is the value of the 1 radian, okay, so what I will do, this is the 2, this 2 pi is multiply here, okay, with the radian here, like the radian. So if I keep 1 here, then I will send this 2 pi to the other side. So what will happen here, this will come down to the 360. So this will be the 2 pi here. So if I calculate, okay, so if I calculate, okay, 1 radian, how much number in degree, so this will be 360, and this is the 2 pi, so the 2 multiplied by 3.14. So the value of the pi here is 3.14, okay. And if I calculate this part, so this will come this number, okay, 57.3 degree. So the 1 radian, okay, 1 radian is equal to 300, the 1 radian is equal to 57.3 degree. So this is the relation between the radian and the degree here. Now, this is the formula for the angular velocity, and the angular velocity is denoted by the omega. So, the name of this symbol, this is a omega. The name of the symbol is omega, and this is the formula. The omega is equal to the angular displacement divided by the time. And if I open this, okay, if I open the del theta, the displacement, so this is equal to the theta f minus theta I is same the angular displacement, the delta theta, and the del t, if I open this del t, so this is the final time minus the initial time. So this is the rule number 1, and this is also same. This is the open form, okay, of the angular velocity. And the unit of the angular velocity is, the unit of the angular velocity is the radian per second. In the short form, we are writing the radian like this, rad, and then dot, and radian per second. So this is the unit of the angular velocity, the radian over second. Now we have the one formula, which is the relation between the linear velocity and the angular velocity. Okay, like this is in this diagram, this is a circular motion, and here the object is moving like here, okay, on this path, and this is the radius of the path, circular path, and here this is a linear velocity, the direction of the linear velocity we are showing by the v, like this is a v, we are showing the linear velocity by the symbol v. Now this rule is telling the relation between the linear velocity and the angular velocity. So this omega here is angular velocity, and this is a linear velocity, and this is the radius of the circular path. Now this is the formula for the angular acceleration, and the angular acceleration is denoted by this alpha. This is alpha. The name of this symbol is alpha. Okay, and the formula for the angular displacement is the alpha equal to the change in angular velocity. This is the angular velocity and this is the change in the time. So the alpha is equal to del omega divided by the del t. So this is the formula for the angular acceleration. And if I open this, this is the change in the, this is a change in the angular velocity. Okay, so if I, okay, so if I open this, then this will be, the omega f, the omega final, minus this is omega initial, and if I open the time, this will be the tf minus ti. So this is the open form of the rule. Okay, otherwise they are same only. And here this is the relation, okay, between, this is the relation between the a. What is the a here? This a is also the acceleration. Okay, this a is also, okay, this a is also the acceleration, but the name of this acceleration is linear. This is linear acceleration and r omega. So the a is equal to, this is r alpha here. So this is the radius of the path and this is the angular acceleration. So this is the angular acceleration, the a equal to r alpha. Now here some the small problems are here. So in the part number a, the part number a says convert an angular position. So this is the angular position. Okay, so here the angular position is given. This is angular position. Angular position is given here. This is 5 pi by 4 radian. Okay, so radian to the degrees. Okay, convert angular position this radian to the degrees. So this is in the unit of radian. So what we have to do, we have to change this radian in terms of the degree, like that. So we know, okay, so we know the 2 pi. Okay, so we know the relation between the pi, the 2 pi and the degree. So the 2 pi is equal to 360 degree. This is a relation between the 2 pi and the 360 degree. Okay, so if I okay, so if I send this to, okay, from here to here, then the pi will be equal to 180 degree. So this is the relation between the pi. The unit of this is in radian and the unit of this number 180, this is in degree. There's a degree coming here. Okay, so this is in degree. So this is the relation between the radian and the degree. So they are saying, okay, so they are saying how to change the radian, okay, to the degree. So what you have, just what you have to do, at the place of this pi, okay, so at the place of this pi you have to feed the value of 180, okay, the 180, and divide by 4. Okay, divide by 4. So when you will solve this, it will come, okay, it will come 225. Okay, so you can write like this, okay, degree, or you can write like this. Okay, both have the same meaning. Both have the same meaning here. So for the part B, an angular position of 4.5 revolutions to radian. So here the angular position is given. This is 4.5 revolutions. I can write in the short form like this, R E V. So the angular position, okay, some angular position is given. Okay, this is 4.5 revolutions. Okay, and they are saying change this revolution, okay, to the unit of radians. This they are saying. Okay, so we can find the relation between the revolution and the radian. Okay, so revolution is nothing. This is a one circle. Okay, so if I move one circle, okay, so if I start from here, okay, so if I start from here and then going to the same point, like as in the circle, okay, in the circle, so I completed the one revolution. Okay, I completed the one revolution, but this is also same. Okay, this is also same 360 degrees also. Okay, this is same the 2 pi. Okay, the 2 pi radians, so both are same. Okay, one revolution is equal to the 2 pi radians. So here, okay, so here how many revolutions we have? Okay, so here our, okay, so it is what number given here? The number is 4.5 revolutions. Okay, so this is 4.5 revolution. We have to change to radian. See how many, so see one revolution, okay, how many radian? One revolution is 2 pi radian. Okay, one revolution is 2 pi radian. Okay, so this 4.5 how many? Okay, so just we have to multiply. So this is 4.5. Okay, 4.5, one revolution is 2 pi. Okay, and 4.5 revolution means you have to multiply, okay, in that number. So 4.5 multiply by this is the 2 pi. Okay, and this will be, now it will come in radian. Just we have to put the value, okay, value of the pi. So here we have to keep the value of the pi, okay, or we can leave the answer in the pi. Okay, then here this is 4.5 multiplied by 2, so this will be 9 pi, and this is the radian. This way we can change. Now here, now they are saying convert the angular position 3 radians. Okay, so here this is given 3 radians, okay, to the revolution. So we have to change the radian to the revolution. Okay, so here the angular position is given what? The angular position here is given, the angular position given here is, this is 3 radian. Now we have to change to the revolution. Okay, so what is the relation between the revolution and the radian? Now if I make one circle, okay, like this, so this is known as one revolution. Okay, this already I discussed. So this one revolution, okay, actually I need to, you know, make the relation between the radian and the revolution. Okay, so the one revolution is equal, same like this is the 2 pi radians. This is the relation between these two. Okay, now if I write, okay, so if I write like this, okay, like the 2 pi, okay, like I'm writing this information here and this information here, easy for me. Okay, so if I write the 2 pi, the 2 pi radian, okay, equal to, this is one revolution, and I want to find the value of the, this is the value of the 2 pi radian. Okay, but I want to find the value of the 1 radian. So if I write here, this is 1 radian. Okay, so what will happen, this 2 pi, this will go to the other side. Okay, because it is multiplied here, so it will go in the division there, other side. Okay, so this is the revolution, and this is the 1 over, and this is the 2 pi, and this much of the revolution it will come. So the meaning is, okay, so the meaning is, here we made a relation between the 1 radian, okay, between the 1 radian and the revolution. Okay, so the 1 radian is 1 over 2 pi revolution. Okay, so here this is how, okay, so here how many radian here? Okay, 3 radian. Okay, so what I found here, 1 radian how much? 1 over 2 pi, like that. Okay, so 3 radian how much? So this is 3 multiplied by this factor. So the 3 multiplied by this 1 over 2 pi, like this, 1 over 2 pi, and this will be revolution here. Now here, you know, sometimes actually Actually the pi. Okay, so here make a note. The note is about the pi value. Actually the pi has the two values. Okay, sometimes we are using the pi is equal to 180 degree. This is the rule. Okay, the relation between the radian and the degree. This, okay, fine. And also sometimes we are using the pi equal to 3.14. Okay, this is the number. So it has the two values. Okay, so which value you have to use when? Okay, like this value you have to use when, and this value you have to use when. Okay, when you are changing only the angle. Okay, when you are changing only the angle. Okay, when you are changing only angle. Okay, there should not be any other thing. Okay, when you are changing only, okay, only the angle value, then you have to use this. Okay, so if it is not a angle value, see, I'm not using, see, this is not a angle here. Okay, the radian, see, if I'm, for example, if I'm changing radian to degree. Okay, yeah, then I need to use, okay, in that case I need to use the pi equal to 180 somewhere. Okay, but here what I'm changing. Okay, I'm changing here the radian to revolution. Okay, in this case the pi is 3.14. In this case the pi is 3.14. Otherwise, okay, otherwise if they are saying change the angle, only angle. Okay, and sometimes if they are saying that change the angle radian to degree. Okay, in that case, or degree to radian. Okay, so in that case you can use the pi, that is 180 degree in that case. Otherwise no. Okay, otherwise this value, okay, 3.3.14. Now okay, so if I put the value here, so this is 3, and this is the 2 multiplied by, okay, the 2 multiplied by 3.14. And if I solve this, okay, so this will be approximately, it will come, how much number it will come, approximately 0.46. Okay, 0.46 revolutions. Okay, so in the 3 radian, okay, there is 0.46 revolution. So this is your answer here. This is the answer in 3 radian. Okay, so this is the answer. Now, so here the question number 1 says, if a rotating disk changes its angular speed. Okay, this angular speed is what? Okay, this angle, when we are saying, when we are saying only the speed. Okay, so this is like that. But if I say the angular speed, this is omega, this omega. Okay, so here they are saying, if a rotating disk, like this disk, okay, changes its angular position at the rate of 60 degree per second for 10 seconds. So this is the angular speed, okay, of the disk. So the meaning is okay, so the meaning is, this is the value of the omega. Okay, the angular velocity, or the angular speed, they have the same meaning. And for 10-second time, so this is the time given. So now they are saying calculate its angular acceleration. So the angular acceleration is denoted by the alpha, this alpha. Okay, so what is the rule for the alpha? The alpha is the value of the omega, the angular speed, and divided by the change in the time. So this number is given to you. Okay, so I can feed here, like this is 60. Okay, this is 60 and radian, okay, over second, and divided by the time is how much? The time is 10 second. Okay, okay, 0 0 cancel. So the value of the alpha, this is alpha. Okay, the value of the alpha is 6 radian. Okay, the radian, because here there are 2 seconds. Okay, 2 times coming. So this is second power 2. So this is the answer here. Okay, so this is the answer for the angular acceleration. Now question number 2. Now the question number 2 says, a car wheel, okay, of the radius, this is the radius of the car wheel. Okay, so if I make a wheel here, this is the wheel of the car, and they are saying okay, this is 0.8 meter. Okay, this is 0.8 meter. Okay, 0.8 meter rotates. Okay, rotates 8. Okay, rotates 8 revolutions. Okay, 8 revolution per second. Okay, rotates 8 revolutions per second. Basically, this is the angular speed. This is the angular speed, okay, of the tire. Okay, so this is 8 revolutions if I write in the short form. Okay, this is 8 revolutions per second, this given. Now they are asking, okay, now they are asking, okay, now they're asking what is the angular. Okay, angular means this omega. Okay, and the linear means the v. Okay, velocity of the tire. Actually the omega is like this, you know, if the tire, this is, if this is the tire, and this is the like angular. Okay, and the linear is like this all the time, like that. Now they are saying, okay, now they are saying what is the angular and the linear velocity of the tire. So here it is, okay, so it is given. Okay, so what it is given here, it is given the angular speed. Okay, the angular speed is given, and this is equal to 8 revolution per second, this given. Okay, and the value of the radius of the tire is given, this is zero point 0.8. Okay, okay, so this is okay 0.8 meter. These two values are given. Okay, so actually I need to write the standard unit for this omega is basically I need to write this information in terms of the radian over second. Okay, so this I need to do. So what I need to do, okay, I want to change this revolution to the radian. Okay, so as I know, okay, so if I make a circle, okay, if I make a circle, so this is a one revolution, we know. Okay, and if the one revolution is equal to the 2 pi, the 2 pi radians. The one revolution is equal to 2 pi. Okay, so 8 revolution, how much? Then multiply by 8. Okay, so what I will do, okay, so this is, okay, so here this is the 8 revolution per second, and if I change this revolution, okay, one revolution is 2 pi. Okay, so 8 revolution, how much? Multiply by 8. So the 8 multiplied by this is 2 pi, and here this is the radian, the radian over second. So this will be 16 pi. Okay, the 16 pi, and this is the radian over second. So this is the value of the, okay, this is the value of the angular, okay, this is the answer of the angular velocity. Now okay, now we have the relation between the linear velocity and the angular velocity. Okay, and the relation is v equal to r omega. Okay, so the v equal to, this is r omega. This is the relation between the linear, this is a linear speed or the velocity, and this is the angular speed or the angular velocity. Okay, so they are saying, okay, so in the second part they are asking this, okay, what is the value of the linear velocity. So here, okay, so the value of the value of the r is how much? Yeah, 0.8. So the value of the r, okay, of the tire is 0.8, and the value of the omega is this. Okay, and this is 16 pi. Okay, 16 pi, and okay, so I need to write the value of the pi, and the value of the pi here I will use 3.14. Okay, so if I calculate, okay, so if I calculate this, this will come how much? If I calculate this, so this will come approximately 40 or 40.1. Okay, so the value, okay, of the linear speed is 40.1 with the unit of meter over second, meter over second here. So this is the answer for the linear velocity. Now the question number 3, the rotor on an helicopter turns at an angular speed of 320 revolution per minute. So this is the, okay, so if this is the helicopter, and this is the rotor, okay, this is the rotor of the helicopter, okay, the rotor of the helicopter, and the rotor is, okay, and the rotor is moving, okay, so this is the speed of the rotor, okay, angular speed. So here this is given, okay, basically this is omega. Now they are asking only, okay, they are only asking, okay, express this angular speed in the unit of the radian per second. Okay, so here the value of the omega is given, this is 320 revolution per minute. So they are saying this should be, this should be radian over second. So how to change? Okay, so the first I need to change this revolution. Okay, so if I, okay, so if I mark here, this is one revolution. Okay, this is one revolution. Okay, and the one revolution is equal to the 2 pi radian. Okay, so this is how many revolution here? This is 320 revolution. Okay, so here the one revolution is the 2 pi. Okay, so 320 how much? Like that much number of the times. So this will be, okay, so if I change only this right now, so this will be 320 multiplied by the 2 pi. Okay, so how, what I changed? I changed this radian. Okay, the radian over minute, this is the radian over minute, but now I need to change this minute also. Okay, so we know, okay, so we know that the 1 minute is equal to 60 seconds. This we know. Okay, so this is downside, so I will like this is 1 minute, so I will change the 1 minute. Okay, so I will change this 1 minute to 1 minute to 60 seconds. Okay, so here I will write, okay, so this is 320 and this is the 2, okay, the pi is 3.14 and the 1 minute is equal to 60 seconds. Okay, 60 seconds. Now if I calculate, okay, so if I calculate this, okay, here by 60, so this will be 33.4. Okay, so the calculation will come 33.4, 33.4. So the value, okay, so the value of the omega, okay, so the value of the omega here, okay, so the value of the omega here is, the value of the angular speed is, this is 33.4 and this is the radian over second. Okay, so this is the answer. Okay, this is the answer in terms of the radian over second. This is answer. Now the question number 4. The question number 4 is, if the angular velocity, okay, this is omega, okay, if the angular velocity of the body in rotational motion changes, okay, from this value to this value, okay, in this time, okay, in this time, so here the two values, okay, are given for the angular velocity. It has the two values. Okay, the value which is given first, okay, so I will assume this is the initial value of the omega, okay, omega I, initial angular velocity, and this is the later value. Okay, so this is the final value, so this is the omega f, okay, like that. So here the omega, okay, so the omega I is the pi over 2, okay, pi by 2 and pi by 2 and the radian over second, and this is equal to 3 pi by 4 and this is the radian over second. Yeah, and the time is given, 4 second, 0.4 second. and the value of the time or the del t is given 0.4 second. Okay, so this information is given to us. Okay, this information is given to us. Now they are saying, okay, now they are saying find the angular acceleration. Okay, so we have to find, okay, so we have to find the value of the alpha. Okay, the angular acceleration, and the formula for this is the delta, okay, the delta omega divided by the delta t, the time, change in time and the change in the angular speed, like that. So here I want to open this. Okay, so this will be the omega f. Okay, and the minus this is omega I, and divided by the change in the time. So here what value given? Okay, for the omega f, this value I'm writing here. So this is the 3 pi, okay, by 4, and then minus, and this is the pi by 2. So I'm writing here the pi by 2, and then divide by this, how much? Okay, this is 0.4 second. Okay, so if I solve this, oh, there are many ways to solve this bracket. Okay, so if I solve this bracket, if I take the LCM of this and this, the LCM will be 4. Okay, LCM. Okay, the LCM of this and this will be 4. Okay, 4 4 1, and this will be 3 pi. Okay, so this is the 4 divided by 2, the 2, then 2 I will multiply by, like here, and this is the minus 2 pi. Okay, so this is the okay, the calculation, and divide by this is 0.4. Now this is okay, 3, this is how much? The 3 pi minus the 2 pi, so this is pi. Okay, so this is the pi by 4, and then divide by 0.4. Okay, so first I will solve this. Okay, so this is 3.14 and divide by 0.4. Okay, so if I calculate this, then it will be, so this will come finally total. Okay, if I calculate then, no, this divide by 4, this divide by 4, this divide by 4. Okay, you know, this one I'm talking about. So this is okay, 3.14, and this is divided by 4, like this. Okay, so if I solve everything, okay, so it will come, okay, so it will come 1.96. So the value of, okay, so the value of the angular acceleration is the alpha equal to 1.96, and this is in the with the unit of radian second square. So the answer for the alpha is this. So this is the answer for the angular acceleration. Okay, if the wheel, the question number 5, if the wheel of radius 0.5 meter. Okay, so if I make the wheel here, and the radius of the wheel is 0.5, okay, 0.5 meter, and with the angular velocity of 4 radian per second, and the angular velocity, okay, this is the angular, like this rotation, and the angular velocity of the wheel is the 4 radian, okay, per second, and the angular acceleration, okay, this angular acceleration, this is alpha, okay, acceleration, this is alpha, and the alpha is the 2 radian per second square. So this is the alpha is the 2 radian per second square. Okay, so this information is given, and the value of the r is also given. Okay, so this is 0.5 meter, so this is a given data. Now they are saying calculate the linear velocity. Okay, linear velocity means the v, and they are saying actually the name actually uh, you know this is the a. Okay, so there are two names basically for this a. Okay, this a, sometimes we are saying this is a linear. Okay, this is a linear acceleration, and sometimes we are saying this is same meaning. Okay, this is a tangential. Okay, sometimes we are saying this is a tangential, this is a tangential acceleration. Okay, both have the same meaning. So sometimes they may say, okay, what is the value of the linear acceleration? Sometimes they may say, what is the value of the tangential acceleration? Okay, so the meaning is they are asking what is the value of the a. So here we have to find the value of the v, and we have to find the value of the a. Okay, and this data is given here. Now okay, so the relation, okay, the rule, okay, between the v and the omega. Okay, so this is the v equal to, this is the r omega. Okay, and here the r is 0.5. Okay, so the value of the radius is at 0.5 meter, and the value of the omega is this is 4 radian per second. Okay, so this is 4 radian per second. Okay, so if I multiply 0.5 by 4, so this will be 2. Okay, and this is the value of the velocity, and this value will be, okay, 2 meter per second. The value will be the 2 meter per second, and this is the answer. Now for the second part, they are, okay, here they are saying, okay, so actually here the first thing they are saying, find this. Now they are also saying what is the okay, so what is the value of the a. So here we have to find the a, this a we have to find. Now okay, so there is a relation between the linear acceleration and the angular. So the rule is, okay, the rule is the a is equal to r and then alpha. This is alpha. Okay, so this is the relation between the linear acceleration, linear or tangential, same meaning, okay, as I told, and this is the r. And here, okay, so if I put the value of the r, so this is 0.5, and I think the value of the angular given how much, the 2. Okay, so this is the 2 here. Okay, this is the 2. So 0.5 multiplied by, okay, 2, so this will be the 1. Okay, the 1 radian, not radian, this is not a radian, this is not a radian, this is meter per second square. This is not a radian, this is 1 meter, this is a, okay, this is 1 meter per second square. So here the value of the a is 1 meter per second square. So this is the answer. Okay, so this is the second answer. Okay, we calculated this. You can do, okay, you can try the question number 6, question number 7. Okay, this is same here. Basically they are asking what is the, this is same idea. Here they're asking what is the value of the v, something like this. Okay, you can do. Now the chapter number 6 is finished.